In section 7.7, we're going to find the distance from a point to a line. I'm going to bring you back to the days in geometry that you absolutely hated, and I'm going to make it a little simpler, actually. Remember in geometry, we had two lines, and I remember you guys hated this. We had two lines, and we had to find the distance between those two lines, and we learned that the shortest distance between 2 points was a straight line that forms a 90-degree angle with that line. And so what we had to do is we had to pick a point, find a point on the line, find the perpendicular line to both lines, and then we had to use that, find the distance between find a point on this line, find the distance between those points, and it was a 7-step process that you guys struggled with and didn't like very much. But we're gonna make it a little simpler in this section by using this simple formula like right here. The distance between a point and a line is simply just using the coefficients of an equation ax plus by plus c, using the coefficients a, b, and then the constant c, all right, when it's set in this form. So we have to have it set equal to 0, and using the point in which we want to find the distance between. All right, so this stands for the point that's given to us, or the point that we want to find the distance from this point to the line. So a times the x value plus b times the y value plus c, all over plus or minus the square root of a squared plus b squared. Again, the same as the section before. The sign before the radical is opposite the sign of c. So if this is a plus, we got to have a negative down there. If this is a negative, we got to have a plus down there. Okay. So in example 1, it's pretty self-explanatory. All it is plugging and chugging. So I'm going to do 3 examples here, and we'll be done. So let's find the distance between 3 and -1, and the line with the equation 2x plus 5y minus 2. All right. Okay, so it says use the coefficients. 2a is what's in front of the x, so it's going to be 2 times x1, which is 3. 3 is the x1 point that's given. And then I'm going to label these two so we know where we're at. Okay, and then plus b, which is 5, times a y value, which is -1. And then plus c, or c is -2, so -2. All over, since this is a negative, we have a positive square root on the bottom. It's the opposite sign. And a squared would be 2 squared, which is 4, plus b squared. B is 5, so 25. All right. And then all we do is just simplify. So here I have 6 minus 5 minus 2 all over the square root of 29. And then here I have 1 minus 2 is a -1 all over the square root of 29. And again, if we want to get the radical out of the denominator, we've done this a billion times this year. Multiply both the top and the bottom by the square root of 29. And we're left over the negative square root of 29 all over 29. That was a lot easier than what we did in geometry, I promise you. So here's another equation here. Find the distance between 0.51 and 3x plus 4y minus 4. Okay, just in case we missed something in the last example, here would be a good time to pause it, try it yourself, make sure you get it right. Our a is 3 times our x1 value, which is 5, plus our b is 4 times our y1 value, which is 1, plus c, or since c is a -4, it's -4. Since c is negative, we're going to have a positive square root in the bottom. A squared plus b squared, so 3 squared plus 4 squared. So in this case, when we simplify, I have 15 plus 4 minus 4 all over the square root of 3 squared, which is 9 plus 16. On the bottom would be square root of 25. On top, plus 4 and minus 4 cancel out, we'd have 15. So right now I have 15 over the square root of 25, which is 5. So the distance between those two, that point and that line, is 3 units. Last one here. Find the distance between these two lines with the equations 3x plus 2y equals 10 and y equals -3x, or 3 halves x plus 7. All right, they just try switching it up on us a little bit, but if we understand what we're doing, we should be able to do this fairly simple. Let's put this in the form ax plus by plus c. So I'm going to subtract my 10 over to the other side and have it set equal to 0. And what I'm going to do, the equation we have is from a point to a line. Right now I have a line to a line. Well, that's fairly simple. All we need to do is we need to determine one point on this line, and that's really easy to do. Just pick an x value, solve for y. All right, pick an x value. I'm going to say 0. 0 is really easy to deal with. So I'm going to do a 7. I'm going to go pick 0. 0 times anything is 0 plus 7 is 7. I have an ordered pair 0, 7. This point is on that line. So if we want to know the distance between these two lines, we pick a point. So this should be the distance from this point to that line should be the same no matter what. So I'm going to take this point, find the distance between that line by using our formula. So A is 3 times our x value, which is 0, plus B is 2 times our y value, which is 7, minus 10. It'd be plus C, but since it's a minus, it's minus 10. Since this is, again, this is a minus here, we're going to make this our square root, so positive plus a squared, so 3 squared plus b squared is 2 squared. Simplify, I have 14 minus 10 all over the square root of 9 plus 4. So on top, I'm going to have 4 all over the square root of 13. And the last thing to do, just get rid of the square root on the bottom by multiplying both the top and the bottom by the square root of 13. So we'll have 4 times the square root of 13. Make sure I get my 1 in there, all over 13. That's it. Hope it helps. See you in class.